In this chapter, we're going to discuss the use of a database in your application. Android provides a full relational database capabilities through the SQLite library. And yes, it's really a library that will be linked with your application. This way, we will avoid the latency of accessing an external system, and also we will avoid dependencies issues. By default, all databases will be private. This means accessible only by the application that created it. We're not going to view all the details of SQL and SQLite. That would be really a complete set of tutorials. But we will focus on creating and using databases within an Android application. The first thing that you need to know is that SQLite is a lightweight open source library and actually a compact C library. It's the same library that the iPhone device is using, as well as many other electronic devices. Another thing that you need to know before we start is the main difference between MySQLite and other conventional databases you may have used so far. With MySQLite, there is no strict type checking. What does that mean? Simply that you can insert whatever data type in whatever column. And when getting data from a column, it's up to you, the developer, to know how to interpret that data. Now we're going to create a very simple application. The layout will be composed of 4 buttons. The first one will create a database and a table. The second one will add some data in the table. The third one will count the number of rows in the table. And the last one will show the different rows. File, new project, my database demo 2.1. So we'll start creating the layout. I will just indent that. And we'll create a first button. With fill parent. Wrap content. I will need also some text here. I will leave that empty for now. And an ID. And I will do that for now, simply because I'm going to copy and paste. And now I have 4 buttons. So the first button will be create database and table, and I will name it my button create. Second one will be add data, my but add. Third one will be count rows, my but count. The last one will be show rows, so my but show. I'm saving. I apparently have something wrong here. Yes, I'm just missing this. That should be much better now. And I can check my layout, which is looking good. So I can now go in the my database demo.java. And of course here I'm going to create my 4 buttons. Buttons but create equals button find view by id r dot id dot create. I'm importing the missing class. So we said create, add, count, and show. Once again, create, add, count, and show. Then I will create my first listener, of course, for the create button. So but create dot set onClick listener, new onClick listener. I will now add the unimplemented method. Whoops, no. Probably need to import first the onClick listener class. And now I'm adding the unimplemented method. And it's time to create some constants that I will use through this code. And I will of course create them just here. They're going to be private, static, and final. So the first string will be the database name, and I will name it jadb.db. Next, private static final string, and we said that we want one table, and it's gonna be simply my table. And next I will create a statement that is going to create this table. Private static final string database create. So this is the syntax: create table, and of course here we're going to add database table, database table plus. Then we're going to create an ID for that table, which will be a primary key and will be auto-incremented by the system. This is not mandatory, but I highly recommend that you do that. So this first column will be underscore ID. It's going to be an integer. It's going to be a primary key, and as we said, we want the system to auto-increment it. And then we're going to create the first column that we'll name colon1. Its type is going to be text, and we're going to say that it cannot be null. And with that being done, we can go back in our listener. In our listener here, we're going to set up a database, and it's going to be an object of SQLite database. Database. And I will name it my database. Okay, I'm importing the missing class. Now we're going to open or create this database. MyDB, and there is a method for that: open or create database. I will need, of course, to provide the database name. Then I will need to say context dot mode private. So mode private here, which is basically saying that we're not sharing it, and null here. So now we're going to execute the SQL statement that is going to create our table. So mydb dot exec SQL database underscore create. Definitely have an issue with this third A of database. So the database create, that is just here. We don't need the database anymore. The job has been done. So I will close the database, and I will just make a toast message. Table created. Short dot show, and that's it. So here we have created a database. Here we have created a table. So we can save this application, make sure that there's no problem. Just some warnings because we have created some buttons we're not using yet, and we can start this application. Now let's see what it's doing. If I click on the last three buttons, of course nothing. If I click on the first one, I have a toast message indicating that my table has been created. Now how to verify that? First, maybe I can re-click here. It doesn't make any sense to recreate a table that is already there. So it should, yes, I have an error, and actually it's worse than that. It's crashing my application. Okay, let me go back here, and now we want to double check, and we would like to really see the database. So we have two ways. The first one that I'm going to show you right now, and another one that we'll see later. A database is really actually a file. So if I go in this perspective and I go in my file explorer here, I can go in data again, and I will look for my com.voxisland package name. Here it is, and here I have a databases and a databases directory, and see I have my jadb.db file, which is my database that has been, you can see the date, and yes, it has just been created, and it's at this time 5 kilobyte of size. So that's the first way to really see the database. And so in a few minutes I'm going to show you another way, and we'll also be able to see not only the database but also the tables. In here I'm going to create the listener for the second button. So it's the button that will allow me to add some data, to input some data in this table. So it's but add, and I can just get rid of those two lines. And here I'm going to create a row. So a row is actually an object. It's a content values object that I need to create, and I will name it new rows equal new content values, and I'm going to populate this object, and you need to do that column by column. So new row dot put, then a key and a value, in other words a column, here col1, and a value. And for this demonstration we're just going to add some OK in this table. And so now it's time to insert that in the database. So my DB dot insert. I need to provide a table. Okay, of course database underscore table. No null colon hack for now, we don't need that, so we can just leave it as null. And values, and here of course it's going to be my content values, in other words new row. Okay, so actually I just realized that I deleted this line that I need to keep. Of course I cannot insert a row in a table that I have not opened previously. No more error, no more problems. And so I can go to the next step, which is creating the third button that is going to count the number of rows in the table, so that will allow us to make sure that those two listeners are working as they should. And here I need to introduce a new concept. The database is never going to return you technically rows or data. It's going to return you a cursor. A cursor is of course an object, and we're going to use this cursor to fetch the data. So the first thing we are going to do here is to create a string, an array of string that will contain the results row by row. So it's a result columns array. And we mentioned that first column name is _ID and the second column is col1. Perfect. With that being done, we can now do a my database dot query, and here see multiple options. Okay, so of course you need to provide a table and then columns, then selections, in other words the where clause of your query, then selections arguments, in other words names. You can redefine the names of the first column, second column of your query. Then we can provide a group by, having by, and an order by. Okay, so that's one way to do it, and I will show you another way to do a query, but I do not necessarily recommend it. But if you want to, you can do mydb, and you can directly do dot row query, and then you will really do here your select star from whatever, where, group by, having by, or you can do your update or whatever. But I think it's better to do that this way. It's easier to read and maintain. So here our table will of course be database name, and then the columns. Okay, the columns. So we're going to return the result. We want the results to be returned in result columns that we have created, this array of strings. Okay, no columns arg and null everywhere, because we don't have any group by, any having, any order, and any limit. We just want all the rows of this table. Just a typo here. Okay. And now what I'm gonna do is, so this query has been executed, and it will return me once again not the data themselves, but a cursor. So I'm creating a cursor object that I will call all rows, and now I just want to count them. So I'm going here to create an integer. Let's simply name it C for count, and it's going to be all rows dot get count. Perfect. So now I will change my toast message, and currently I have to change this. So table created, no. We want to say count, and I will concatenate that with C, but since it's an integer, I need to cast it in a string. This reminds me that here it's not table created anymore, of course, it's row added. That's perfect. So let's now save, make sure there's no issue, just one warning, which is the last button, not using it yet, and let's test. So I'm going to add a first row with add data, perfect, and when I'm counting, well, when I'm counting it's crashing. So let's have a look and investigate that mistake. Yes, okay. Of course, here it's not database name but database table. The database name has been opened with the open or create database, and here if I want to run a query I need to provide a table, not a database. Stupid me. So I'm going to count first. Okay, that's perfect. I'm adding 2 rows. Counting, it should be at 3. Yes. Okay, another one. And I'm now at 4. So we just need now to implement the last listener. This one is going to show us the different rows. Button show. And here I will create a result string, and I will have this header. Result is, and I'm going to go through all the different rows that I have, and I will use my cursor for that, and then I'm going to use, that's not ideal of course, but I'm going to use a toast message to show the rows. So I'm creating here a column index, because when you look for, you'll see that when we will be looking for a column, we will not provide its name, we need to provide its index. So we'll create that integer now named cIndex, and I say all rows dot get column index of, and that's this column that I want to show, col1. So we're going to use that integer pretty soon. Now I have to remember that maybe my table will be empty, and trying to fetch a cursor that is empty would not be a good idea. That's why here I have a if all rows dot, and see for row cursor I have different option. I will do the move to first, which is going to return false if there are no data. So if there's no data, it's not going to do that, this do while that I have here. So do and while, and of course here I need to jump to the next item or to the next row, and I'm going to do all rows dot, and here I have move to next, and I'm going to concatenate the call col1 column of the row in my result res variable. So I'm going to do a all rows dot get string, and that's here that I need to provide a column index. So I'm going to use my C index here, and I will just add a dash to separate the different rows. And of course here can get rid of that because I will just show the variable I built. And let me make sure I use the same name everywhere. It's created here, res, so yes, of course here it's res. So once again, it's not necessarily ideal to use a toast message for that, but for a demo it's okay. Oh, I still have a warning here, and just because I don't need that C integer anymore, I'm going to remove that. No more warnings. I will count the rows till 4. So if I show them, I have 1, 2, 3, 4 OKs. 1, 2, 3, 4. I'm adding 1, and now I have 1, 2, 3, 4, 5 OKs, which is exactly what we were expecting. So you know how to create a database, you know how to create a table, you know how to add data, count, query the database, and now we're going to see very briefly, I will not necessarily run those examples, but we're going to see how to delete and how to update data. So let's start with deleting. Very easy. You need to provide, of course, a table, and here it's going to be, it would be a database underscore table. Then database table. Then you need to provide a where clause. For example, underscore ID equal 1, and where args. In most cases you don't need that. And this is how you're going to delete the first row, or at least the row with ID number 1. Updating now. You still need to provide a database table, and now you need to provide data columns. Just create a content values and provide it to this update method. You will have a where clause indicating on which set of data you want to apply this change, and that's going to do the update. It's also important to really understand what you can do with the cursor. So we're going to see the different options. You can do, of course, as we have seen, move to first, move to next. You can also do move to previous. You can do, as we've seen, get count. But you can also do a get column name, which is going to return the name of a specific column index. Very useful. Very useful also get column names with an S, which is going to return a string array of all the column names in the current cursor. So that's something that you may need from time to time. We can also let me look for it. See here, use move to position if you know exactly where you want to go. And if you're lost, this can happen. You can always use the dot get position right here. So here I think that would be a good exercise for you to maybe play a little bit with those cursors, maybe create an application, create a database, a table, and add data, delete some, do updates, and use the cursor to navigate through the different rows. I think that's something that will show you the different options that you have when using a cursor. And I remember I told you we're going to have another tool to see the database and the table and also the data themselves. So if you remember, in one of the first lessons we used ADB with ADB devices, and here it's telling me that I have an emulator running, so I can do ADB-E for emulator and run a shell on this emulator. And like I would do with Unix, I can navigate through the file system and go in /data com.voxisland, and here I have a databases directory, and here I see my JADB.db database. So I can run a SQLite client, SQLite 3, and I need to provide the database name. And you can do a lot of things here with this client. You can do .help to have a view on the different options you have. You can do .schema. Schema is showing us that we have two tables, one created by Android itself, and we have, of course, the table that we have created, my table, on which we can, for example, do a select star from my table, and I see the 5 different rows I have in this table. And here we could also do updates, delete. So it's a very convenient way to do some troubleshooting, debugging, to insert fake data in your application to test it. So that's something you might want to use from time to time. Now, what we have seen so far was pretty low level, but you also need to know that there is you can have a higher view. You can build what is called helpers on the top of the low level functions. You can see those helpers as abstract classes that will really wrap up the best practice pattern for creating, opening, and upgrading your databases. In other words, it will hide the logic used to decide, for example, if a database needs to be created or upgraded when you want to open it. We will not necessarily in this chapter going in the details of helpers, because with what we have seen so far in this chapter, you have everything you need to learn by yourself and understand how helper works and how to build helpers. You will find a lot of examples on the internet, so you can just Google Android SQLite helpers. If we would do that together, it would really take a lot of time for, I think, quite nothing, because honestly you will see it's something that is pretty easy and very logic. And once again, with what we have seen here, you have everything to understand what a helper is. And here you go, you have an exercise for this chapter. So once again, you can do some Googling, and you will see that a lot of people are sharing their implementation of a SQLite helper. So try to understand what they are doing. And another very good exercise also would be to create a helper by yourself. So open one of those abstract class and do your own implementation. It would not only be a very good exercise, it would also be something you could reuse in the future to help you and facilitate the data access and manipulation in your future applications. Have a lot of fun.